Ideas are powerful drivers of change. They fuel improvement and open up new possibilities. The first of its kind in the Philippines, in partnership with the Department of Trade and Industry, a fabrication laboratory or Fab Lab in Bohol was established in May 2014 as part of a global network of local fabrication laboratories that nurture ideas. A space for co-creating, innovating, learning, and sharing knowledge. To foster local economic growth and community advancement through creative solutions, DTI, through FabLab, has identified 4 areas of development: innovation, MSME assistance, capacity development, and collaboration and partnership.
A Fab Lab is an interdisciplinary space that promotes innovation through the use of digital fabrication tools. It's a modern facility that allows our SMEs to do prototyping. For the last 1.5 years, we have been teaching them digital fabrication skills, which are very much in demand in the world market.
For us, it really would support creation of maybe high-end products and development of new enterprises that are technology-based.
This one will be the common service facility of industrial designing in the province of Bohol. There are even seminars, conferences, workshops conducted here so that Fab Lab enthusiasts and other designers could use the facility.
The concept was introduced to us by our Japanese volunteer, Mr. Yutaka Tokushima. He noticed in the course of his product development activities here, he noticed that a lot of the problems in prototyping could be solved if we had the right equipment to do it.
We've catered SMEs to really expand their market into the tourism sector.
We have all these industries, and ang thing is, they're all, kalat-kalat, and they're all spread out. And I think having this Fab Lab would, bring them all together.
True to its thrust in catalyzing innovation, DTI, through Fab Lab and its local partners, has initiated key programs, projects, and unique initiatives in the areas of waste upcycling and material engineering. Prefabricated shelter designs, startup support and development, equipment development, and knowledge hubs for new innovations and technology-based solutions.
The timing man nga abot ang tagahapon nga mo naa sila ihatag. So mao to nga nalipay may kay ni ani abot ning Kiwi. Kiwi House nga mo gi magkaroon na mo serve as daycare center.
Key MSME assistance initiatives such as product design, product development, productivity enhancement, and marketing solutions have been significant drivers in the improvement of grassroots entrepreneurs and homegrown innovators.
We do some native bags, placemats, wallets, curtains, and lately I do trophies and medals for the triathlon with the use of Fab Lab facilities.
The problem that artisans face here in Bohol are really the same challenges that any small business faces across the world, and that's how to get your product in front of your customer. So we developed a kiosk called the Made in Bohol kiosk and sought to have it located in the luxury hotels where the tourists were staying.
Pag butang nimo aning dating molder na mo, pag butang nimo, patigasin pa. In pila ka minuto pa usa pa nimo matanggal. Pero kini siya, gasigi pamighimo ana, kasi mo iwa pa mahuman ng uban, pwede na mo siya itaktak kay gahi na. Wala na kay minuto o oras nga magamit aron pa mo gahi aron maputos. Kani siya diretso na. Mas daghan, mas napasayon, mas niangay ang among customer. So dako kay natabang ang Fab Lab sa mua.
Ang improved na siya nga sticker namo sa bagol na siya kay ang among canister is naka-embed man siya sa taklob. So kani siya sa bagol na siya. Okay, before, mag-cut out man ni, kami mag-print, ordinary lang nga bond paper ang gigamit, kami na sila mag-cut. So, karon nga naadirig, introduce siya sa DTI. So, try ko nga magpa-print. Ganahan na sila. Sila, oy, nindot lagi mag-packaging. O, kaan lagi ni, klaro kaayo. Oy, sinaw na lagi ni. Kanang nga na siya, na mga feedback na yun, ana.
When FabLab came, we had this partnership with them para maging competitive din tayo sa market. So, eto po yung isa sa mga naitulong ng FabLab. This is our newest package na po sa mga placemats po namin. Madami po kaming nabenta na po nito. And we're very thankful to FabLab. Tumaas po yung income ng kooperatiba. Kasi may added value po yung mga produkto na namin.
To fuel global industry competitiveness, local entrepreneurs, students, and innovators are brought together to equip them with 21st century skills and tools through digital fabrication, technology trainings, and livelihood trainings and seminars.
It's for everyone. I would say a lot of people really likes to make almost anything. Doon, merong bata, merong matanda, merong zero knowledge, merong may medyo alam na. When you see people came in and then yung parang may sparkly eyes sila dito, when they came like, oh, pwede pala to siya, pwede palang gumawa ng ganito.
The Department of Trade and Industry conduct workshops and trainings for those because they want also to help those young local people here in the country. Because they want also to enhance their skills, improve their skills by the use of the FabLab Bohol. So, because FabLab Bohol, the concept of FabLab Bohol is to innovate and to create inventions by the use of digital fabrication.
This FabLab should be duplicated in other regions because this is a good avenue for developing the skills of designing on the students' part so that we could be ready or we could be at par with other countries in designing.
It's actually, for me, it's like a gold mine for innovators because everything are there na. Laser cutter, the shop boot, 3D printers, Arduinos, mga testers na ito.
As of now, there are so many micro and kitchen-based enterprises that would really need to improve or upgrade their technologies, their equipment. And that's why we are supporting FabLab because it is our vision that this facility could help those in making those customized equipment.
The FabLab affords its users access to global knowledge through regular educational tours and access to the international FabLab network. Local and other Philippine startup communities, enterprises, designers, and enthusiasts are encouraged to collaborate amongst themselves to expand and strengthen their niche in various market networks.
ボホールではファブラボを使って、必要なものを必要な分だけ作るというイノベーションが徐々に現地の人の手を使って生まれてきています。これは、他の国のファブラボでは見られないようなボホール独自のイノベーションと言えるようなものです。
The laboratory boasts of an array of digital fabrication equipment which include a laser cutter, 3D printers, a digital embroidery machine, a print and cut machine, a CNC milling machine, and an automated wood milling machine. FabLab Bohol also houses a pool of passionate in-house designers and highly skilled staff who can assist in 2D and 3D design, skills training, modeling, and production.
Our task here is to assist those researchers, innovators. So what we did here is not for us to create their idea, but them to create by themselves, and we will assist.
In partnership with the DTI, Bohol Island State University, DOST, and the Japan International Cooperation Agency, or JICA, and the local community of enterprises, FabLab stands at the center of innovation in Bohol.
We are very thankful of the help of the DTI. They can give you a very good service and you really can come up with a very good product.
Kasi we want to be Gandum Weavers to really soar high. And our partnership with FabLab will bring us to that level. So thank you po, FabLab and DTI.
I encourage everyone, especially taga Bohol, mga students, mga innovators, or mga out-of-school youths, try mo sa FabLab. If ever wala pa niyo nakita ang imuhang gusto himuon, no? Basin na mo kita sa FabLab.
It's a great privilege bitaw sa ato kay nga natagan tag chance nga matagan og FabLab diri nga makita mo ma-amaze jud mo sa mga magama ni FabLab matabang niya para nato sa Bohol.
If you wanted to build a robot or night vision goggles or just something that lights in the dark, this is the place for you.
I would like to invite everyone to come at FabLab and let's play with these machines and let's work that idea out.
きっと皆さんのアイデアと、ボホールが持っているイノベーションがそのコラボレーションすることによってさらにもっと面白いものになると思います。ぜひ皆さんボホールにお越しください。
FabLab Bohol, a place where ideas turn into reality. Ideas that can improve lives, not just for Boholanos, but for all Filipinos.
Lab UP Cebu, and I will also be your host for this afternoon's webinar. So this afternoon, these activities we're having are brought to you by the Department of Trade and Industry in partnership with the Department of Science and Technology's Advanced Manufacturing Center, or AMcen for short, in which we celebrate FabFest 4 on November 24 to 27, 2020, with the theme Fabricating the New Normal. So FabFest 4 will be having a series of webinars, this being the second, in which we will lead up to the eventual festival itself that will feature local and international experts who will discuss various topics on innovation and design. So these events are brought to you live right now via Zoom and Facebook starting November 4, 2020. So these webinars are expected to gather a wide range of Fab Lab enthusiasts, the general maker community, students, faculty, and various stakeholders in the innovation sector of the Philippines and beyond. And so we have a really exciting guest with us this afternoon, all the way from the Netherlands, who will be discussing desktop filament making, breaking new ground in the development of production and recycling of 3D printing materials. Here to give us a rationale and introduction of the speaker, can I call upon Senior Science Research Specialist from AMcen, Engineer Leaf Colorado. Engineer Colorado, are you there?
Hello, I'm here. Hello. Hello and welcome to FabFest 4. I'm Leaf Coronado from AMcen. We all know that our technology is evolving and continually changing our lives. One of the state-of-the-art technology is 3D printing. Nowadays, we can almost print anything we like, from simple and even complex designs using different materials. But have you ever wondered if we can use recycled plastic as a high-quality filament to develop your own customized material? Our speaker today is an expert in this matter. He is a solution advisor and integration specialist who has been working in the 3D printing industry over the past 3 years. His passion for communication and circular economy allow him to help companies to improve internal processes, develop procedures, and achieve their goals. Please welcome Mr. Pedro Lima. Ano?
Hello everyone. Well, I think good afternoon for everyone there in the Philippines. Here is early in the morning. It's about 7 a.m. My name is Pedro Lima, and I work at the Dutch company 3Devo. So before starting to talk about our company, about what we do, I would like to thank the organizers of the FabFest, together with OmniFab, which are the parties that are having me here today and are giving us this opportunity. So thank you everyone for making this happening, and to have us here. Well, in this case, to have me. So who's 3Devo and what we do? So basically, we are a young Dutch company that we have developed a material processing, recycling, and developing solution. So we have developed equipment that allow other businesses and allow other companies to grow bigger, to actually improve the internal processes, to actually have full control over their material processing, recycling, and developing unit. So I'm talking basically about additive manufacturing when it comes down to transform plastics, transform, let's say, plastic waste like bottles or bottle caps or food containers, or to transform waste generated by processes when it comes down to failed prints, scrap parts, or support materials into high quality filament for 3D printing applications, okay? So our solution is basically, what we offer is a solution that is composed of a filament maker, a plastic shredder, and a polymer dryer. So as I said, with our solution, other businesses, other people like Fab Labs, universities, maker spaces, and many different types of institutions, they are able to actually recycle plastics, recycle different types of materials, right? So as I said, it could be common plastics like household plastics from, I don't know, PET bottles, bottle caps, food containers. It could be like shampoos, you name it, any kind of plastics, and also any kind of like other materials that people might have at hand, such as PLA or ABS failed prints, or nylons, and then you can actually grind them down, you can dry them up, and then you can transform into high quality filament. So you can actually feed your printers, you can actually develop your own material at your own pace, and then you can use these materials for different applications. And on top of that, our solution also allows you to develop your material further. So let's say that you have plastics and you want to improve the mechanical properties of your materials, or if you want to change the way the materials behave, or if you want to actually create a new formula for a different application. So you can actually also blend different additives to your plastic. So you can also actually add fibers, you can add minerals, you can add ceramics, metals, you can add powders, and you can add colors, for example, to your materials, to your filament. So you can customize your own filament, you can customize your own materials, you can even come up with new formulas or new composites for different applications, okay? So in a nutshell, that's what Credivo does. So we provide the material processing, developing, and recycling solution that allow other businesses to have full control of their material process, actually make their own filament at their own time, at their own pace, okay? And what do I do? So as I said, my name is Pedro, and I work here at Credivo, and I'm a solution advisor and integration specialist, because what I do is that I see what other companies need, what other institutions actually are struggling with, and then I analyze their needs, their issues, or what they can actually improve, and therefore I provide the best solution. And that's when it comes down to recycling, material developing, and processing, okay? So it's important to mention that here we are talking about transforming plastics and actually blending additives to different plastics in order to create high quality filament for 3D printing applications, okay? And moreover, I also, of course, right now, this has been a very challenging year for everyone because of the pandemic, but also I normally travel all over the world to educate our clients, our audience, by providing them information about material processing, about recycling, about filament making. So I go to conferences, I go to fairs, I give speeches and lectures all over the world. So this is something that I really like doing as well. But unfortunately, this year has been very challenging. Of course, traveling is not allowed. We have to make sure that we listen to health officials and we follow the guidelines. So of course, this is part of my job that I'm not executing today, but due to technology like Zoom, we are able to get closer to each other, like here today. So we have been doing a lot of maintaining and trying to be present internationally via the technology. So as I've been saying, is our technology capable of? What do we do? So basically, there are three main applications that we use our technologies for, which is recycling, and that means getting, let's say, there's a university, we collect, let's say, a university collects plastic waste from the campus, like the bottles, the food containers, the bottle caps, and any other plastics that might be there. And they would just recycle those and transform those plastics into high quality filament. So that would be one of the applications, which is recycling, as well as if, for example, if like a university or a fab lab or a makerspace has a lot of 3D printers, and therefore they print a lot, and therefore they might generate a lot of failed prints or scrap parts or support materials. You can also recycle those. You can shred them, you can dry, and then you can put into the filament maker and transform that into filament. And then you can reuse your plastics, reuse your materials, and you just give a new purpose for plastic waste in general, either if it's just waste coming from the trash can or is waste generated by internal processes, by 3D printers, for example. So that's the recycling application. The second application would be research and development. So let's say that a university is running their 3D printing facility or a fab lab or a makerspace. Besides recycling, they also want to develop their materials further. They want to modify the properties of their materials, or if they want to create a new formula. So with our filament makers, you are also able to actually add additives to your material. So universities, for example, they do a lot of research on new formulas, on how different materials would perform, or actually even how to create different materials, different filament for different applications. So for example, you can get PLA or you can get PET, and then you can add, for example, carbon fiber or glass fiber to that material. So what's going to happen is that you're going to create a filament which has higher mechanical properties, which has more strength, which is less brittle, for example. Or you can just actually collect a lot of bottles, and then in the end, if you mix a lot of bottles, if you transform a lot of bottles into filament, you're probably going to have a big mix of colors. So you can actually add master batch, and then if you add master batch to your bottles, you can actually change the outcome, the color of the outcome. So the master batch is a colorant. So you can actually add. Okay, I think someone is saying something, but yeah, so then you can actually add colorant or master batch to your recycled plastic, so you can change the outcome, you can change the color, so you can see, you can just, as I said, you can develop your material, you can change the outcome, you can add additives to your materials, okay, to your filament. And the third application would be production. So that means that nowadays, like more and more companies, they are getting aware of the benefit of making your own filament, of recycling. So, and there are a lot of farmers, meaning that there's a lot of companies now that they have a lot of printers and they need a lot of filaments. So they just go for like kind of mass production. So they line up a lot of machines that will be constantly providing them with filaments, so they can either like feed their 3D printers for prototyping or tooling applications, or they can also actually sell spools off the shelf, right? So that will be, so those are, to sum up, so there are three main applications: recycling, R&D, and production. What's our mission, and what actually do we do? How do we see the industry, and what's our goal? So a lot of people know about 3D printing. They know what 3D printers can provide you with, what they can make, and what's the final goal that you can achieve, what are the final pieces that you can create with a 3D printer. However, a lot of people don't know the steps before 3D printing. And that's where we come in, because our solution actually is an equipment that actually allows you to make the filament, to make the material that is needed for 3D printers to print. So a lot of people, they say, oh, I have, or let's say I have a 3D printer. How am I going to use it? I'm going to buy filament. And filament is quite costly. Filament can be hard to find. And therefore, we have a goal, or we have the mission to educate the industry, to educate the audience, to say, okay, look, there's a solution in which you can make your own filament at your own pace. So you can actually create your own material, your own filament for your 3D printing applications, for your 3D printer. So you don't have to buy filament anymore, but you can actually use the plastics that you have at home, like the shampoo bottles, the water bottles, the food containers, or any type of thermoplastics or plastic waste that you have at home, and you can actually, or in your facility, and you can actually transform that into filament, and you can make your own material at your own pace. You can develop your own filament actually to use on your 3D printers, and to actually boost and improve your 3D printing capabilities and applications. So we try to show that filament making is a very important step, is a step that is feasible, like that is out there already, that people actually can have access to. So therefore, you can actually help the environment by recycling plastics that are already out there, and by transforming those into high quality filaments. So you are repurposing plastics. At the same time, you are also having full control over your material processing unit, meaning that you can actually decide which kind of plastics to use and when to use those and when to transform those plastics into filaments. So you can do that at your own pace. And furthermore, you can also develop. So besides recycling, you can recycle plastics, but you can also add additive to your plastics, and therefore you can customize the filament that you're going to have. So we try to increase the awareness of filament making and material processing in additive manufacturing for 3D printing applications, because it's a very useful and helpful process. And actually, this gives you a lot of flexibility, autonomy, and freedom to not only recycle plastics, but create your own filament. And therefore, you can actually decide what to do and when to do it. So basically, you have then a full access or a full control over a filament processing unit, right? A filament processing procedure. And as I said, a lot of people know about 3D printing. They know what 3D printers can do. However, we think it's very important to also go out there and show people that you don't really have to always rely on filament maker suppliers. You not always need to buy your filament, but you can have access to equipment, to machinery that allows you to make your own filament at your own pace. Therefore, you can improve your internal processes. You don't really have to depend on third parties to get your material. You can actually collect plastic and make your material yourself at your own pace, So that's what we try to do out there, that we try to show this part of the industry, the additive manufacturing industry that is growing, that is actually a complement for the 3D printing solution, right? It's a complement of 3D printers. So you have the printers, however, you also have the filament makers, which are the machines that are gonna allow you to make the filament that are used on FDM 3D printers, okay? So that's kind of our mission, just to go out there and show that we are there to help other companies to develop their materials, to make their own filament, and therefore increase the speed in which they can create their own material internally. Then you can actually reduce lead times when you're talking about getting materials from suppliers. And of course, you're going to be helping the environment, because you're going to be recycling and transforming plastic waste into filament. You're going to be getting more sustainable. You're going to be adding your company, your facility, your students, your employees, your staff into a circular economy. And of course, you're going to be, in the end of the day, you're going to be helping the world. As we all know, there's a huge plastic issue everywhere. And if there's an opportunity, or if you can actually get the plastic that is already out there in the nature, harming the environment, and actually reuse it and transform that into filament for 3D printing applications in which you can develop industries, you can give people opportunities, you can help poor communities with recycling facilities, with fab labs, you can invite students, you can invite young people to come and bring up their ideas to create, to develop. So then you're not only helping other people in communities, but you're also helping the environment, the ecosystem, and it's just something that we think is very important, and that we feel like the obligation to go out there and tell people about, actually just open the eyes of people and say, okay, look, there is a way that you can make your own filament, that you can recycle plastics, that you can give plastic a new purpose, and therefore you can use plastic for 3D printing, for making, for developing your organization, for giving opportunities to people, and to help the environment. So that's more or less what we do as well. And as I said, the main applications of our solution are like recycling, doing R&D, research and development, and production. So I just want to say, I want to give some examples of like some industries that are using our equipment for filament making, for recycling, and for, of course, additive manufacturing. And after that, I just want to give I'm going to mention some industries, and I'm going to give some examples so you guys can put this into perspective and visualize a little better what other companies like universities, fab labs, maker spaces, and innovators are doing with our solution. So some of the industries that are heavily using our material processing, developing, and recycling solution that I think is important to mention, that is also composed of a plastic shredder, a polymer dryer, and a filament maker, because the process is the following. You get plastics, plastic waste or support materials or failed prints. You have to put them into the plastic shredder. So you grind your materials, your plastics. After that, you dry the output, the recycled regrinds, because most of the plastics are moisture sensitive. So you really need to remove the moisture in order to be able to process the material. And once you have dried the shredded material, you can put the material into the filament maker. So you transform your material into filament. In a nutshell, that's the process. So you shred, you dry, you transform into filament, you print, you fail, you repeat. So it's a closed loop cycle, right? So you can keep on doing that over and over again. So therefore, you can always keep on using the materials you have at hand, and you can always make your own filament, your own materials at your own pace. So what are the industries that are using this kind of technology or this kind of equipment? So I'm going to name a few for you. So educational institutions are using that, such as universities, colleges, and high schools. Okay. So there are a lot of those institutions using this solution for not only recycling, but also for doing R&D, developing materials further, and for, you know, feeding their 3D printers and in their fab labs, in their labs, and in their maker spaces as well. Other industries that are using this kind of solutions are chemical companies, the automotive industry, the aerospace agencies are using, the research centers and research labs, designers and innovators, and of course, a lot of 3D printing service providers. They are also using the type of solution because it gives them a lot of flexibility to create, to innovate, and to design. Okay. And then, of course, I would like to give you guys some examples so you can actually put into perspective how these facilities or how these people are using such solution. So imagine you have you are part of a university, and then you have, of course, a lot of students on campus, and there's a lot of plastic waste being thrown away, right? Because the students, they consume like drinks, they eat things that come in containers, and therefore there's plastic everywhere. So we have clients, universities all over the world, because we are active in more than 45 different countries. So we have, for example, universities doing that in North America, in South America, in Europe, in Asia, and in Africa, for example. So there's a lot of plastics in the campus. So those universities, what they do is that basically they collect all the plastics, right? And then they collect the plastics, the bottles, the bottle caps, the food containers. They separate plastics because you need to separate their plastics, because different plastics, they have different processing specifications, different processing characteristics. So you have to separate your plastics. So you separate the bottles from the bottle caps and the food containers, and then you divide them in type by plastic type. And then what they do is that they take all these plastics and they bring to their 3D printing facility, to their recycling center, such as like maybe there's a fab lab already inside the university. So what they do is that they make all the students collect those plastics, those bottles, those bottle caps, those food containers, and they bring to their facility. So they shred, they give opportunity to the students to get involved, to the process, to the staff to get involved. So they shred those plastics, they dry those plastics, and they put those plastics into the filament maker. So they transform the plastics into filament. Why do they do that? Why are universities doing that? Because they are actually teaching students about material science, about how students can actually process their own materials. And most importantly, they are like actually showing students the positive impact sustainability has on the society, and sustainability has on processes and procedures, because these students are, for example, being added to a circular economy. So they are seeing that plastics that are being thrown away, they can actually be used for making material, creating material, and therefore they can use that material to get even more creative on 3D printing. So they can design objects. They can design, for example, any different types of, like for example, phone cases, or gadgets, or souvenirs, or keychains, or they can design different things that can get creative, and therefore they can actually print out those objects, those parts. They can do a lot of prototyping for concept. For example, engineering departments, they do a lot in universities. They do a lot of prototyping because students have a lot of opportunities to get creative, to do engineering, engineering projects, such as like creating objects, creating robots, parts of cars, just putting engineering efforts together. So actually students that have the opportunity to do prototyping with those recycled plastics. They also can do tooling. Sometimes universities or fab labs or maker spaces, they need tools for their applications, or so you can design tools. You can actually design support pieces for many different types of, so we have this type of clients doing that. So I think this already gives you an idea of like how you can actually recycle plastic waste and how you can bring that to a useful level, right? Moreover, universities have a lot of, they have PhD students, they have labs, they have research departments. So besides recycling those plastics and transforming like common plastics into filament, the universities, those departments such as the labs and there's research facilities, they also take those plastics and they
Ako sila grades are 10K per month, good. Ato dili get 35 per hour.
Sorry, I don't know, someone said something. I'll just keep going. So
sorry.
Was that a question? I'm sorry. Was that a question? Should I answer a question or can I keep going?
No, I think he just accidentally unmuted his mic.
Okay. Just for you guys to know, of course, after I finish talking and presenting this to you guys, there will be space for questions. So I'll be glad to take questions and answer them all if necessary. Okay. But as I was saying, so these universities, they also, besides recycling, they also research and develop materials further. They do a lot of research and development. So for example, they take those plastics, they analyze them, and they try to get creative and come up with new formulas, new concepts of materials that can be modified or materials that can be created and therefore used for different types of applications. So for example, you can take, like these departments, they take PET, like PET, which is a type of plastic that I normally found in plastic bottles. And they add additives such as fire retardant additives to PET. So what do? They create layers that can be used as fire retardants for fire cut doors. That, for example, you add a layer of PET with fire retardant additive to a door, this door becomes a fire cut door, meaning that if a building is if there's a fire somewhere, like this door will prevent the fire from progressing, for example. This is, so we, like with this kind of technology, you have freedom and the ability to actually get even more creative and add different additives, such as fibers, like carbon fibers or glass fibers or minerals or wood, or for example, metals, ceramics, graphene. So you can add additive manufacturing and having a solution that allows you to create your material at your own pace actually also allows you to develop your own formulas, to develop your own materials, to modify properties of existing materials, and therefore customize your own filament. So you can actually bring something new to the industry, or bring something new to your university, to your fab lab, to your maker space that can be used to enhance final objects, to enhance the creation of different pieces, different parts. So there's also the research matter, right? That also you can get deeper even. You can study the distribution particles of new compositions, new filaments, new materials, how they behave, what they could be used for. So that's also something that comes with the solution. So not only the recycling, but you have the R&D part, because you have flexibility to blend new additives with plastics and therefore customize your filament. And therefore you can come up with new applications, new uses for new filaments. Okay. And there is also another very interesting example that I want to give. This is something a bit different because, for example, as I said before, there are aerospace agencies using our solution for creating their own filament, for creating their own customized filament for their own applications. So, for example, we work with the European Space Agency. They allowed me to share their name, so that's the reason I'm telling you. The European Space Agency is using our machines because it's a very, we just put out a very, we just have written an article, a case study and a blog on that because it's a very interesting case. So the European Space Agency is using our machines because basically they had this idea of doing maintenance and space. So basically what they do is that they bring their crew with a little 3D printing facility inside their rocket, let's put it that way, or their spaceship. And they have a little 3D printing facility in there in which they go to space with that, and they have our plastic shredder, our polymer dryer, our filament maker, and a 3D printer there. And what they do is that while they're on space, because they have long missions, they have long-lasting missions, they develop their own material. They recycle the material that they have at hand already there, because of course, if you are there, you cannot get access to material. So what they do is that they reuse and they develop their own material to create their own tools and their own high-resistant parts for actually replacing failed parts or components of the spaceship, or for example, for creating a new tool that they need to use to make the maintenance of certain parts of their spaceship and space. And moreover, lately they have found out that they can actually add lunar powder. Yes, you heard it right, lunar powder to PLA. So PLA is a very common plastic. And this aerospace agency, the ASA, they have found that they can actually add lunar powder to PLA. So what does that mean? That means that actually they bring less plastic to space, because there they can have access to the lunar powder, so to the moon in that case. So they bring less plastic to space, and they have found out that it can actually add high percentages of lunar powder to PLA. So they reduce the amount of plastic that is being used, while they actually have increased the properties of the material, the mechanical properties of the material, and the resistance of the material for creating tools and parts that they need for doing the maintenance of the spaceship. So how crazy and how interesting that is. So this is also a different application that is going on, that thanks to 3D printing and additive manufacturing, more specifically filament making, allows them to actually have all this flexibility and this autonomy to actually develop their procedures and actually keep their projects and their missions going while they're on space. So we are getting to a level that additive manufacturing and 3D printing are giving people a lot of flexibility. They are actually improving a lot internal processes, and they are actually allow people to get creative, to bring up to the table new ideas, new solutions. So therefore, I think this is such a so fascinating industry, a so fascinating part of this whole additive manufacturing, 3D printing matter that is happening nowadays, because it gives you a lot of flexibility. It allows you to do a lot of things at your own pace. So, you can get creative. You have a lot of freedom and flexibility to decide the outcome of the material, the outcome of the piece, or the outcome of any component that you might need. So you have a lot of flexibility to do so. So I find that very interesting. And one last example that I would like to give is that we have a very active client, is a Swiss American company. And what they do is very fascinating, because basically they are helping poor communities in Africa, most specifically in Uganda, in Senegal, in Mali, and in Zimbabwe. So what they do is that they bring containers, so like those containers, like ship containers, they bring those ship containers to poor communities in those countries that I just mentioned. And what do? They actually build a fab lab and a maker space and a recycling facility inside those containers. So they bring a filament making and recycling solution to those containers, and they also equip those containers with 3D printers and computers. So actually, they allow the communities to bring plastics to those facilities, plastic waste, and actually even more, they actually not only allow those poor communities to bring plastics to those facilities, but actually they provide all the resources, all the machines. They teach those communities, those people, how to use the machines and how they can process their own material at their own pace. So they give these people jobs because they are actually kind of like hiring them to give them opportunity in exchange of financial reward. So they pay them, they give them salary. And at the same time, they allow these people to get creative and to bring money back to the economy. So they give these people jobs, and they allow them to recycle plastics, transform plastics into filament, print with those plastics, and actually create souvenirs, create phone cases, create objects that can be sold for tourists in souvenir shops, in little shops around the countries, around the communities. And at the same time, they are keeping people off the streets. They're providing people with opportunity. So it's very interesting what they're doing. So they're doing that over several places across Africa, South Africa, Central Africa. So they are actually bringing to people with less resources, with not that much condition, tools, spaces, hope, love, and all these things that actually comes together with the technology. So an opportunity, of course, and in the end of the day, they're providing these people with something to do, with happiness. In the end of the day, these people, they have their salaries, they can have food on their table, they can help their family. So my point is that the technology is not only helping other companies or other business to develop further, but they're also helping people to actually have an opportunity, have a purpose, have space to create, to help their communities, to help their families, and to have a job, So I think that's very fascinating. This company is active I believe, in 6 or 7 different countries in Africa, and they have been doing that over the past 2.5 years, and it has been very successful. We're gonna also be writing a case study and a full report. We wanna make a documentary with that as well. So again, like those are some of the applications, some of the examples that I can give you, so you can just put into perspective how additive manufacturing, filament making, 3D printing are being used in nowadays. And I think that's also emphasized the positive aspects of sustainability, of going greener, of circular economy, because you're not only helping other businesses, processes, and procedures, but you are also giving opportunities to people. You are also helping the environment, because I have been in Southeast Asia, for example, and I've been to some beaches in Southeast Asia that I was shocked by the amount of plastic waste that was dumped on the beach. Like, I went to places, and for example, to give you an example, I went to places myself in Indonesia. And when I got there, I had this idea that they were like lost paradises, and they were, don't get me wrong, they were beautiful. However, there are some places, some beaches with so much plastic waste just basically dumped on the beach that I was like, okay, look, this is not right. We should do something about it. And that's what 3Divo, our company, does. We go to those places as well. We try to look for communities there, for companies that we can partner up and actually help them, and provide them with tools that they can actually help their countries, help their nation, help their people by taking those plastics from the environment, giving a new purpose to those plastics, transform those plastics into filament so they can print with those plastics, and therefore generate opportunities, jobs, or help companies, help institutions, help people, help students. So this is something that we do. So I think it's very important that I mean, just to mention that, just to show the magnitude of the problem we are having worldwide with the plastic issue, and how we are, of course, we are one company, one organization, and now we are having more partners that are helping, but it's just like part of our mission and our goal as well, just to, provide this vision, this kind of education to people as well, and show what tools we can offer, we can provide, so other companies, other communities, they can also, improve, grow, and just help help their environments. So this is something that I would like to mention here, because I think it's a nice thing to say, and a lot of people don't know about it. A lot of people don't know about what it takes, what are the technologies that are available, and that's one of the things that we do. So we go out there and we try to tell people and about the importance of additive manufacturing and material processing on recycling and on you know, on the environment, on the society, on circular economy in general. All right. What else? And yeah, I think I kind of covered a lot of points here. I think I kind of explained how additive manufacturing, how material processing can be used for recycling and for creating your own filament, for 3D printing. And I think something that might be interesting is that, okay, more and more we see that some materials, which is nice to see, like some materials are becoming more trendy in the industry. So more people are using a set of materials that are common plastics. And I would like to mention, so we see now there is a hype or a trend, especially in Europe, in North America, in Northern Africa, and in Southeast Asia. There more people are actually getting more conscious about recycling. Also because governments are regulating more, meaning that if you work with plastics, if you consume plastics, you need to prove that you need to show what you are doing with those plastics, and you need to prove that you're not throwing plastics to the environment. You're not just dumping. So more and more people are getting more conscious, and also people are 3D printing is growing. People are also having more 3D printing processes and generating more issues. More waste with their internal processes. So recycling is something that is getting into evidence. Either if we're just talking about plastic waste in general, or if we are talking about waste generated by internal processes such as like failed prints or scrap parts, or support material. So as more people are getting more conscious about that, plastics that are more easy to find, for example, HDP, which you can find, which HDP is polyethylene, high density polyethylene. And where can you find that? You find a lot of HDP or PE as well, which is polyethylene, in food containers, in bottle caps. So if you have a plastic bottle, normally the bottle cap, if you look at it, you will see that bottle caps are all made of HDP, LDP, or PP. So LDP and HDP are low density and high density polyethylene, and PP is polypropylene. So you see that those plastics are being used more and more, because you see that companies are kind of, or other institutions are more into recycling. So they are recycling more, because those plastics, they are mass produced by injection molding or by companies with mass production processes. And they are, in the end of the day, and they end up in trash cans. So people are using those plastics now more and more. They are giving these plastics new purpose. So you see that more companies are recycling, which is nice to see. So I would say that there's a trend now for HDP, LDP, and PP. Like those materials are being used a lot. Moreover, PET, which is PET, is the plastic that you can find in plastic bottles. It's being more and more like it's getting more and more visibility. More people are using this material, because this material actually has good mechanical properties, is a strong material. So it gives you a good final finishing for end pieces, for components, for parts. So more people are getting to know that these plastics that are already out there, such as PET, have a lot have a lot of value. They can be used for many different things, and they have they can be just taken from the environment and they can be used. So we see that a lot of companies, a lot of institutions are using more as well PET. And of course, you see that a lot of people use PLA and ABS. Why? Because PLA is in theory is a accessible material, and it has very good extrusion and printing capability. So it has very good extrudability and printability capabilities. So especially in maker spaces and fab labs, a lot of people use PLA because PLA is a material that you can get your hands on, is easy to work with, is user-friendly, is probably the most user-friendly material out there because it's easy to transform into filament and is easy to print with. So, and therefore, those materials, they're very much used, and there's a lot of scrap parts, a lot of failed prints, and a lot of waste that is generated by this process, whether it's failed prototype or just the prototype is not as good as it was supposed to be, or the prototype was just in the initial phases. So you end up with a lot of those parts, a lot of these pieces, and they can be recycled, they can be reused. So if you guys have parts, have a lot of pieces out there, a lot of, like, let's say, failed prints, scrap parts, support materials, plastic waste out there, just keep in mind that you don't have to dump, you don't have to throw it away, you don't have to put aside. There are solutions. There's a possibility that you can reuse that you can reuse those plastics, you can develop them further, you can transform those plastics, that waste into filament, and then you can still be using those on your 3D printers, on your facilities for many different types of purposes. So just keep that in mind, that if you guys have a lot of waste, or if you have access to waste, either they come from trash cans or they come from processes, internal processes, just keep them aside and keep in mind that there are ways out there to reuse those and to transform those into filament for 3D printing applications. So it's nice to keep in mind that, you know, that exists. There are companies such as our company doing that, and it's something that can be done, right? So just keep that in mind, that's important. And as I said, those materials that we see more and more being used, or companies coming to us, people getting to us and say, look guys, do you know HDPE? Do you know PP? Do you know PET? Do you know PLA, ABS? But mostly I'd say the PP, HDPE, LDPE, PET. Do you know those materials? How can we use those? We see them all over the place. Do you have experience? And more we see that there's more demand, more companies are using those materials for their applications, which is nice, because that also emphasizes that more people are getting more conscious about the environment, about plastic waste, and of course about material processing, which is nice, which is like one step before 3D printing, because then you can make your filament, and after that you can print with it. So it's nice to see that, you know, little by little people are getting more aware of the possibilities of transforming material into filament, transforming plastic into filament, and have actually the flexibility to create your own filament at your own pace. And yeah, I think, I don't know, I lost track of time. I don't know for how long I have spoken already, but I think in a nutshell, that's what we stand for. That's what we do. I think that's how the industry is moving at the moment. I see the 3D printing and the additive manufacturing as fascinating industries. I think there are a lot of developments to be made, but also the industry is growing very rapidly. And I believe that this is the future, because 3D printing, additive manufacturing empower people, gives people like a lot of flexibility, freedom, and autonomy to grow further, to develop their processes at their own pace, to get creative. So I strongly believe that the industry is going more towards a production level, meaning that right now 3D printing and filament making, of course, is improving, but it is still overall, it can be to some extent a detailed process. Sometimes it can be a long-lasting process. Sometimes it takes a little longer to print, but the technology is evolving. The industry is developing. We are moving forward. And I believe that once 3D printing and additive manufacturing get to a production level, meaning that you can process everything that we process right now. You can actually create everything that we create and process everything that we process right now at a high level speed, like let's say in minutes, in less than hours, then that would be a game changer for the industry. And then I strongly believe that who does not have a 3D printing and an additive manufacturing technology in-house by then would be running behind, because I really think that the future is like empower people more, give people more flexibility and more speed to create. And that's where I believe that the industry is moving to, is heading to. So overall, I just think that we are in the right path. Like overall, as part of being part of the industry, I can say that overall, I think we are in the right way. We are moving towards, I think, a more sustainable and more flexible future when it comes down to empowering people, empowering young minds, like creative people, and just providing people the right tools and making sure that they can express their ideas, that companies can develop further, get more creative, provide more opportunities, and keep the industry going and keep helping the environment as much as possible as well. So guys, I think that's how I will be wrapping this up. I think I could probably explain a little more and show you guys a bit more of what we do, what the industry is doing, and how additive manufacturing, filament making, of course, and recycling and 3D printing is being used nowadays, and a little bit of what we see on our end and how we perceive the whole industry as a unit. So guys, thank you very much for listening. And I think now, I'm not sure, but I think now we're gonna have some time for questions. Correct me if I'm wrong, but I just want to thank everyone for tuning in, for being here. Also, once again, I want to thank the FabFest for this opportunity, as well as OmniFab, who made this happen. And thank you, everyone, for having me. Appreciate it.
Hello, Pedro. Thank you so much for that really fascinating talk. So we will be entertaining some questions, of course. So we'll give people a bit of time to gather their thoughts, and we'll answer a few questions. Maybe you can answer some of my questions
Sure,
in the meantime, because I actually just got back from the Netherlands because I studied there for a couple of years, and so I worked with some people at the Precious Plastic Project, and so this is really fascinating to hear and to see your processes. It's in a more commercial scale, I believe. And I'm curious with the service aspect of 3D Evo, in that you talk a lot about helping all these institutions in processing their plastics or their plastic waste, or to help encourage them with recycling. It's I feel that the sorting aspect is a big challenge, well, in what I've observed anyway. And do you guys encourage a certain kind of sorting? Like, do you have mechanical sorting, or do you just encourage everyone to manually put it in bins?
Good question. And well, thank you very much actually for mentioning that, because I didn't want to get so technical. But yes, that's definitely a very important part of the process, because we have to keep in mind that there are a few things that you need to take into account when it comes down to material processing. And one of the parts is, like, you need to make sure that you have you segregate different types of plastics, because different types of plastics, they have different characteristics, different melting points, and they behave different. So you cannot mix all plastics together. So one of the parts of and then we call that the sorting, we call that the pre-processing. So basically, let's say that you're gonna gather like plastic waste. So you have to make sure that you separate, for example, the bottles from the bottle caps, because they are made of different plastics. And of course, you have to keep in mind that contamination is a problem, is always an issue. So you do not only have to separate the plastics, but you also have to make sure that you wash and you clean the plastics properly before processing the plastic. So to answer your question, yes, we emphasize that part as well. We know about it, we know the importance, and we provide guidance. So there are machines and there are tools that can separate plastics for you. However, right now at this point, those solutions, those machines, they're quite big, they're very costly, and for a lot of, let's say, young companies or companies that are trying to get established, they're not very feasible, because it's a huge investment, it's a huge compromise. So what we try to do is, like, teach people how to separate plastics, how to wash their plastics, and how to have all the plastics ready for then starting processing them, So normally what we try to tell people is actually to have a pre-processing kind of like procedure in place, meaning that you can have like people that would collect the plastic, then you can separate them in containers, and then you can wash them, you can dry them up and have them, you know, like separate in different containers, in different boxes, and then you can start processing them. So that's what we would recommend, you know, and that's actually what we would tell people to do mostly.
All right, okay. So it's very practical, and in the end, you still have to rely on people's effort to really sort everything at this point. We have a question here from Diane, where she asks if there are any limitations to the type of plastics that we can transform into 3D filament.
Okay, well, Diane, thank you for your question. That's a good question. So we have to keep in mind that here, like that when we talk about plastics, we are talking about thermoplastics, right? And what's a thermoplastic? A thermoplastic is a plastic that can be melted and that can be cooled up, because those two factors, they allow us to transform the plastic into filament, okay? And most of the plastics, luckily, are thermoplastics. So basically, if we're talking about thermoplastics, which are plastics that can be melted and cooled up, we can process them all. There is no limitation, okay? So it goes from like PLA to PET, ABS, PETG, PP, nylons, and also we can go to the high mechanical range thermoplastics such as PEEK, PSUs, PEIs, PPSUs, PACs, which are plastics that are, like have a really high melting point. So as long as we talk about thermoplastic, we are talking about plastics that can be processed, okay? Sorry, did I answer the full question? And then she also asks if I'd like the limitations. Yeah, so the limitations I would say, okay, is knowing whether it's a thermoplastic or not, and the considerations for certain plastics that are suitable for 3D printing. So as I said, like this really gonna depend on your application or what you want to achieve. But most thermoplastics are suitable for 3D printing applications. However, of course, you also have to keep in mind that you need to know what kind of 3D printer you have and what kind of limitation your 3D printer has, because there are specific 3D printers for a specific range of plastics that can be processed, and of course you have to know that. Okay, so yeah, I'll say that the limitation is knowing, like, okay, what's your end goal? What do you want to achieve? What kind of printer you have, and then you can probably put on the table a range of plastics that you can use with. But bottom line is that all thermoplastics are suitable for 3D printing. Some plastics can be more challenging, some less, but overall all thermoplastics are suitable for 3D printing.
Okay. I have a question on, let's say, the filaments themselves. I'm quite curious about like the overall quality compared to, let's say, a brand new roll. Would you say like you could really say there's a difference in terms of like how strong the material is? Would you say like it's brittle to a certain extent, or do you have to store it differently from a brand new roll?
So are you talking about mainly the difference between recycled filament and like virgin filament? Okay, cool. Yes. Yeah. So good question as well. So basically there's difference between recycled filament and virgin filament, okay? Because the difference is the source of the material, because virgin filament is normally virgin material is normally chemically made or is processed. So the properties are capped. The properties are super strong and they are 100% capped. So if you process virgin materials, you're going to have a virgin material spool, which has the properties, its properties completely intact. Okay. However, once you recycle plastics, you go to a grinding phase, and the grinding phase breaks the molecules, breaks the particles and the particle chain, or the molecule chain of the plastics, and that damages little by little the mechanical properties of the material. What does that mean? That doesn't mean that you're going to have a bad impact when you print with those materials. However, you need to keep in mind that materials, they also have recycling cycles. So for example, if you recycle PLA up to 4 times, you can use it with no major issue in the end. However, if you keep on recycling PLA, I'm taking PLA as an example, but that applies to all other plastics, thermoplastics. But then if you keep on recycling PLA too much, at one point, the material is going to completely lose its mechanical properties, meaning that it's going to be very hard to print with, and it's going to get very brittle as well. So what you can do, you can always keep on recycling. However, after a certain cycles, and that changes according to the different types of plastics, you can still recycle, but then you have to add a little of virgin material to your recycled plastic. So after a couple of cycles, you can add, for example, depending on the material, I don't know, 30 to 45, 50% of virgin plastics to your recycled regrinds, and therefore you recover the properties of the material. So you can always keep on recycling. However, you need to know how many cycles you can recycle your plastic.
Okay, that's good to know that, like, even if you've been constantly using it, just introducing new material could actually like bring it back to a useful state again.
Definitely.
Okay. Oh, go on.
And just to answer your question, so basically the spool of recycled material and the spool of virgin material, they have the same characteristics as long as the recycle cycles of the recycled spool has been respected. Therefore, if you print with both, you're going to have pretty much the same end pieces, the same properties. Okay. That's basically, you just have to know. You just have to respect the limitations of the plastics. And of course, that might get a little technical, but we are always out, like if people have questions about the more technical question, oh, how many cycles does this material have? Or you can always get in touch with us and then we can provide you more information. But it can get very extensive if we start, discussing about every single plastic in a specific.
We will take your word for it right now. I'm actually also curious about one material you mentioned where you used lunar powder. Did you actually like come in contact with that material?
We unfortunately not, because what happens is that, as I mentioned, the European Space Agency is using our machines to actually, and they have created that material with our machines. And actually, we didn't even know about the project beforehand because it was. How can I say, was top secret, was private, right? We just got to know the project once they made it, they have approved and validated it, and then they told us, and therefore they authorized us to write about it. And we thought it was fascinating. So we were like, oh, definitely we want to get involved and we want to, get to know every single step of the process. And then they told us everything, but we ourselves, we have never had access to the material, and we don't have a first-hand experience with the material. However, we are and this is brand new. We just dropped the blog post and the case study last Thursday. So it's totally new. So now we are getting more and more in touch, but we were fascinated by what they have done. And once they said, okay, you guys can write about it, we just wanted to share with everyone because it's really something that you don't hear every day,
Yeah, it's crazy to think that one of your products actually reached outer space somehow. Yeah. Did it actually reach outer space? Yeah. Yeah. No.
Yes. Exactly. So now what they are doing is that they are bringing. I'm not sure if it's already there, but the idea now is to bring the product, the machine. They bring the products and the machines there, so they can start now using those materials for their applications. So yeah, but they have done that already because that's with the new material. But they were already using our machines to recycle PEC, which is a high mechanical property thermoplastics. But they were already doing that, but now they really have knocked out of the park with this lunar powder, which is something totally new.
It's out of this world, literally.
Yeah, literally, yes.
Okay, going back to Earth, specifically here in Asia and the Philippines. I'm curious if you mentioned that you already have people using them projects here in Asia, or would you know in the Philippines if 3DVO has any kind of presence?
Yeah, we do. We do have a presence in the Philippines. We have actually. Okay, I'm gonna put it this way. Like before, we used to do everything ourselves, including we would have a direct sales business model. But most recently, because of the demands and because of the development of the markets in Asia, including the Philippines, we decided to partner up with someone there. So we have, can I mention their name? I think so, right? Or not? Okay.
I don't know if there's any problem, but it's if it's fine with the as you wish.
Okay, so yeah, there's a company called OmniFab there, which is our partner, and they are our partners, and they are helping us to increase the reach of our technology in the Philippines. And therefore, we have a client, we have a university there already who has our full set. Actually, they have acquired a couple of machines even, and they're going to be using those for recycling and for material development as well. So yes, we are fresh in the Filipino market, but we are already present there. We are very happy, and we want to actually we hope that we can help more organizations, more companies there, more businesses, more people, more communities. So we are very excited about that. But to answer your question, yes, we are already present there.
That's super exciting to hear. I wonder if there's anyone from that university who's actually in this talk right now, just to see if they've tested it out. But that's really exciting to hear. If there are any other Fab Labs or universities that would also like to get you guys on board, what's the best way to do that? Is it through your partner? Is it through you guys?
I mean, like I think I'm not gonna talk for my partner for our partner right now. I'm not gonna give I think their details, but what they can do, because I'm here speaking, and I think they are already by now familiar, or they got to know the name of our company, 3Divo. So in case they have questions, they would like to have any further details or get to know our machines in the Philippines or get more involved with it, they can always get in touch with us directly. And what I would do is then I will point them out to our partner there, so they can, have a local assistance already, So I think at this point, they can always get in touch with 3Divo, and then we will point them out to our partners in the Philippines, so they can, have a kind of like in-person, of course, right now is a bit more challenging, but when things get better, they can have more in-person, approach and kind of like experience. So either way, they can get in touch with us. And if they want, they can also get in touch with our partner there, which is called OmniFab.
All right. So everybody, if you are interested and would like to have their presence in your university Fab Lab, then you know what to do. Always looking forward to in-person meetings at this point in this economy anyway. Maybe one last question. I'm curious about what is next for your company, and that like you're already doing so much for recycling and processing in terms of services and products. Are you going into researching beyond recycling already? Like, I don't know, bioplastics, things like this?
Yeah, so basically what we do right now is like, of course, we provide the equipment, but that's not all, because we provide also a lot of training. So as I was saying, like one of our mission is like to educate more and more people, increase the awareness of material processing and recycling. So what we do is that we not only provide equipment, but we provide training, we provide guidance. We have increased our material specialists. So we have a team of material specialists that they do like basically what they do is that they investigate, they do a lot of research on different materials, on different thermoplastics, on different composites, different blends, additives as well. And right now we are running a huge project on basically just making sure that we can actually transform the most common plastics such as PET or PP, like, household plastics, into high quality filament, because up to last year, like the whole industry was using additives to improve the extrusion properties of recycled plastics and the printability. And we don't want to do that, because we provide the recycling solution. So we want to make sure that our solution can provide people with a fully recycled output. And that's what we are doing. And that's why we ran a huge project on PET, on recycled PET. Like literally we were collecting bottles around the Netherlands from universities, because we are based in the Netherlands. So we were collecting bottles from different universities, from supermarkets sometimes, to actually run those tests. So we are running a lot of trials on processability of recycled materials right now, because this is one of their main focus is to like make recycle more accessible and make recycling actually more evident for everyone. But furthermore, we are also like developing new technologies. So a couple of different equipment as well. I might be disclosing that later on. Right now, I'm not really allowed to disclose because it's a prototyping phase, but you guys can stay tuned because for 2021, we're going to be putting out exciting stuff out there. Also, we are also working on a cloud application, meaning that we want to have our machines, we want to have our users being able to control our machines through a cloud solution, meaning that you can control the machines or the solution through an app that we are developing right now. And of course, it's very important to mention that last year we put out the dryer to close the loop because we had the shredder and the filament maker. However, drying is a big part of the process because you need to get rid of moisture. So we also put out a dryer last year, and we have developed an application ourselves, which is called Devo Vision, which allows you to connect the filament maker to your computer, which means that you can have a real-time overview on your extrusion, and therefore you can improve the quality of your filament, the quality of your spool, and your results. So basically you can see the flow, the diameter consistency, you can see the current that is being used. So this is an application that we put out as well, like I think 1.5, 2 years ago, and actually helps a lot our users to have the solution fully integrated into their applications.
All right, that's super exciting. I just looked through your website and looked through all these products. They're really, really exciting to see. So I think it's 3devo.com. If anyone would just, after this webinar, go check out their website so you can see the full array of products and services that they have. I think we don't have any more questions. I guess everyone is just really excited to have you here this afternoon for us, this morning for you. Thank you for waking up quite early to give us this webinar, Pedro. And yeah, thank you so much. We really appreciate all the valuable information you've given us this afternoon about your company.
Mona, thank you very much for your kind words. And once again, thank you very much for putting this together, for this opportunity, for having me. As I said, it's a pleasure. Like that's what I love doing. I love the industry. Part of my job is also, like, as I said, trying to put like put our point across, pass the message on, trying, like just to open some eyes and spark some like brilliant minds out there that I'm pretty sure you're full of brilliant minds in the audience. And yeah, once again, thank you everyone for tuning in, for being with me throughout this journey here. Mona, once again, thank you. Thank you. I'd like to thank your team. And guys, in case you would like to talk more or have questions or would just like, I don't know, brainstorm any topic, you can write me directly. Mona, can I leave my email here in case, or should I just leave the website? Yes, of course, please. Yeah. So guys,
as you wish.
I'm just gonna leave my email here, guys. So feel free to drop me any messages you might have, questions, if you like to brainstorm anything. Like I'm here to help, and that's what I do. So I'm gonna drop my email here in the chat. So if you guys have any questions, feel free to reach out. I'm also gonna drop our website here, so you can browse through it. You can check what's new or what we have available. And guys, once again, thank you everyone. Great to have this opportunity here. I hope everyone stays safe. Please follow the measures. Make sure that you protect yourself and your family, your loved ones. And yeah, just thank you very much, guys. Appreciate it.
All right, you take care too. And so before we go, I just want to remind everybody that we have several webinars lined up this month leading up to FabFest 4. The next one is going to be on November 9. We've got 2 lined up for that day. So we've got speakers from Singapore and Belgium. From Singapore, we have Lee Chen from Mark Forge, where he will be discussing carbon fiber and metal 3D printing in education and fab labs. And for our Belgian speaker, we have Brian Clavicilias from ANSYS, who will be discussing pervasive simulation solutions for metal fabrication. If you want to know about the full list of webinars or just stay updated on what other events we have lined up for FabFest. You can always check us out on the Department of Trade and Industries Region 7 Central of Visayas Facebook page. And so I think that wraps it up for today's webinar. Once again, thank you everyone for coming. And my name is Mona. I'm the manager for FabLab UP Cebu, and I'm also helping out with hosting a couple of these events. I hope you enjoy, stay safe, and yeah, thank you everyone.
Thank you, bye-bye.
Bye-bye.